All right, this is week 10, and this is our PLC class, and we are going to record both of these problems today. Going over problem 1, creating a function that accepts 3 integer values and returns the largest. So here I have done my first problem on structure text, and it is a function, and I put if integer 1 is greater than integer 2 and integer 1 is greater than integer 3, then time block will be equal to integer 1. And as you can see, that kind of goes down with the rest of the same line as I have if integer 2 is greater than integer 3 and integer 2 is greater than integer 1, then we have it set to integer 2. So our end statement is going if time block is less than 0, then time block will be equal to 0. So we can see I have made this into a function block here in my main program right here as I set my I1, I2, I3 as integers. We're going to go ahead and turn this on and we're going to show you how it runs. We're going to first set our values. Let's just put this as 1, 2, and then 3. And then this should spit out 3 right here since it's the largest value. So we hit start. Oh, I'm supposed to hit write all values, I think. Yeah. Okay, hold on. Well, fine. Hold on just a second. Okay. So we're going to hit run. So as you can see here, it says 3, and that's what we are expecting for problem 1. And for problem 2, I made my motor starter as simple as any common in industry. It's just a start, stop, motor run in parallel with motor run. So I go to question 2. Let me go offline so I can show you what I did. And I have my counter up timer with the positive edge, run PI parallel with press reset. And here I have my start count. As you go down, I have my move block going from run, and I have a positive edge. Time going to time start. Next one, I have my move block going from run PI, and I have my negated contact. And as you can see, if you do current time plus total time, it'll come out with the total time. And as that's what we're expecting in our output. And we have here our another move block. If we have with the run, if we have time minus time start, it'll give us our current time. And if we see the next network, it's going to be, so run PI is going to be negated. As you can see, our current and max time greater than our other move block. We have our current time as an input and our max time as an output. Our last network, we have our move block and we have our reset pressure indicator, and we have our time minus time start, and that'll spit out our current time. So we can see this run by seeing the counter go up. So everything is at 0 just as we expect. If we go here and we hit our start as true, we should see a counter go up just like that as we expect, just like that, and then it's running. And you can see that running through here. You can see that running through question 2. And if we hit stop and start, it will start our count again. So let's go back and stop this so we can get this to go up to 2. Stop. Okay. So now we're going to go true again, write all values, and this should bump up to 2. Oh, sorry, that's got to be false to go false. There we go. So now our count is at 2, and that's what we want. That's what we want for problem 2 when it asks us to create a runtime and a motor start counter. The input should be running indication. When the running status is received, the start should increment. As you can see, I just demonstrated how that went up. We can keep on playing with it while we hit this to true. We can make that stop. Okay, so if we make that to false again as it's still true at the start, we'll see it go up to 3. Oh, negative. Okay, we're going to make this false. Should go up to 3. Bam. So that is problem 2. And as you can see, these are our function blocks I used for both problem 2. I have the motor starter function block set in ladder diagram, and my question 2 is set into ladder diagram. You can see the count start at 3. As you can see, these are all moving the way it should be. So that is problem 2, and this is week 10.